Hello ladies and gentlemen, this is Mr. Mayer, and in this video we will discuss reflections on the coordinate plane. Your directions will say decide if the figures are reflections of each other, and if so, state the line of reflection. So I've got two examples for you. The first one, we have to decide if triangle ABC is a reflection of triangle VZW. If it is, give that line of reflection. So to get started, what we want to do is we want to look to see, well, first of all, do they look like reflections? Remember, if it's a reflection, it's a mirror image. Well, they're looking like a mirror. They're looking like they're facing opposite ways. So that's good so far. So let's go ahead and continue then. What we need to do is figure out where could a line of reflection land such that this triangle would be reflected to look like this triangle. So you're maybe noticing already this line, this y-axis. In fact, let's go ahead and always label our axes first. Y is up and down, x is side to side. You're noticing that this triangle is a lot closer than this triangle is to your y-axis. So that's kind of already telling us the y-axis is not going to be the location of that line of reflection. A good practice, a good way to figure out where this line would land is to just go ahead and figure out how far away are the points from each other. I see that A is supposed to match with the V. So let's figure out how many boxes are V with A away from each other. If I count 1 box, 2 boxes, 3 boxes, and 4 boxes, so it's a total of 4 here. Now let's put it this way. We're looking for a line that's right in the middle in between these, so I can flip the first triangle over it in order to create the second triangle. To find the halfway point, well, there's 4 boxes. Halfway would be 2 boxes. So I'm thinking this would be an important point for us to think about because there's 2 on either side. Let's see if we can do the exact same thing with 2 other points. So if I look at Z compared to B, Z is 1, 2, 3, 4 boxes away again. So therefore halfway in between would be 2 and 2. So 1 box, 2 boxes would be this point. And that's exactly what you want to do, ladies and gentlemen, in order to figure out where your line of reflection lies. So at this point, what I'm going to do is just connect these 2 points. And I found my line of reflection. So to finish this one up, we just have to give it a name. It's not name it whatever you want. We have to use specifically the information that's provided on our axes. Now, notice, I went side to side in order to create this line. So going side to side, how far did we go? Well, got kind of covered up here a little bit, but this is a -1. -1 on which axis? The x-axis or the y-axis? This is what confuses people. Let's put it this way. We moved to the left. So if I move to the left, that is side to side, which is the x-axis. And there we go. That line is x equals the value that it landed on. So this is the equation that I'm figuring out. Now, we're not totally done with this one yet. We didn't check our last 2 points because guess what? If one point is different from just one other point, they're not going to be reflections. So we have to check, is W the same distance to the line as C is to the line? So let's go ahead and count. 1, 2, 3 boxes. 1, 2, 3 boxes. Perfect. Phew. All of these matched. Yes, this is a reflection. Okay, that's how to do these. Now, I want to do one more example. This one is definitely trickier. Maybe you're noticing why. Again, same directions. Decide if triangle EDC is a reflection of HGF. If so, give that line of reflection. Well, last time we flipped it over a vertical line. If I flip it over a vertical line, then my triangle should be over here. So that didn't work. What about a horizontal line, side to side? If I flip it over side to side, then this original first triangle should be directly above it. So I'm running out of options. Why don't we go ahead and try that same idea we did last time, finding midpoints, the middle points between the vertices or the endpoints, the corners of your shape. If I want to find the midpoint between these two, well, just go ahead and draw a little straight line. If I draw my line right here, the midpoint, it's going to be about there. A little rough, it's not exactly on a box like that. So why don't we just continue it? This one, a little trickier. It looks like it might actually even end up on that same point again. Be a lot better if we went ahead and did this. Now, again, when we're dealing with slants, it gets a lot more confusing. So the best way to deal with this when we're working with slants is to just go ahead and count side to side, up and down. How many boxes would it take to get all the way down from E down to H? So let's go ahead and count. 1, 2, 3, and 4. 4 boxes down. How many would it take to count side to side from E to H? Counting over. 1, 2, 3, and 4. Interesting. So if we're using our rule from before and it's supposed to land halfway, why don't we just take half of these values? So I'm just going to count down instead of 4, count halfway. 1, 2, 2 is half of 4, perfect. Count over another half of 4 this way. 1, 2, and there is my point. What you've done, you've enabled yourself to find 2 points that lie on the line, so you can just connect them, and you've got your line of reflection. Okay? Now, we have to be specific. We have to be able to name this. So at this point, what we have to figure out is, does this line have a special relationship? Is there anything special happening? Let's take a look at the points where it crosses on the grid. I've got over 1, up 1. So this is 1, 1. I've got over 2, up 2. This is 2, 2. 3, 3. Negative 1, negative 1. Negative 2, negative 2. So what I'm noticing, for every x value I have, it's the exact same y value. The equation of a line that has the x values and y values the same is y equals x, because they're both equal. This is your equation of your line. Again, a great way to double check and make sure that it is correct for all the points is just to go ahead and count. So I'm going to count. How long is it going to take, or how many boxes will it take for me to go from each point to the line? So I count up 1, count over 1. Perfect, 1 with 1. I'm going to go ahead and do the same thing for G with D. G is up 1, 2, 3 boxes. D is over 1, 2, 3 boxes. Perfect. Last one was E down to H. We already did this one. E down to the line was 4. H over to the line was 4. Perfect. All of these match, and therefore triangle EDC is a reflection of triangle HGF. Thank you all for tuning in. Hope to see you soon.